My name is Varshit and now we are going to discuss the topic about beyond the relational database model. Well, while revising the 10th edition of book called Database Processing, he is a printing hall at the year of 2005. One chapter that XML data storage will eventually eliminate relational database and the horrified review strongly recommended software language. And before the database system, we have the file operations to add, remove, and delete. And the horrified reviewer strongly recommended software language like XML for data transport and but eliminating relational database. But why not? We need relational databases when XML document stores will do the job better. By taking the structures the user provide and break them into pieces. Although we can really transform XML documents into normalized relational tables. And why not? Simply store XML documents. The more I thought about it, the more it became obvious to me. Well, the problems with the normalization. In the year May 1985, while serving as Microsoft's vice president of development, he spoke with a customer who had just installed the new relational base 5000 and was having trouble with the documentation and it want to use it to keep track of invoices. And she explained looked under index and invoice wasn't there. I, they thought maybe called them sales orders. So they looked under found so much entity. During the next hour in through the process of creating five normalized tables customer, salesperson, invoice and line term and hooking them together with foreign keys. Then they explain how to rejoin them to get her sales and long into the call. She asked why I am doing this. So they ended ever had been a normalization garage, the one where you pull on their car into the lot and your crew runs out and removes your left front tire and places it on the pile of the left front tires. And which means remove your right front tire and places in the right pile of right front tires and removes the steering wheel and places it in the pile of steering wheels. Then, when you retrieve your car, the crew reassembles it from the separate piles. Why would they do this? For the convenience of managing the garage, to have fixed length piles, to index the piles, to ensure that you don't have more than one steering wheel. After 35 years of a computer science and numerous iterations of more than 18 month cycle, isn't there a better way? Well, relational model relationing. The relational model is a set of theoretical model for describing data constructs into a common in the business environment. Having any sort of theory in the 1970s was important for legitimacy. I recall then common joke. How do you know the real sciences? They don't have science in their name. Consider chemistry, physics and biology versus administrative science and social science and is computer science relational database also minimizes data duplication which ensures data integrity and reduces storage requirements. The latter factor which was particularly important in the 1970s when disk capacity was quite limited. The IBM 2311 stored only 7.5 megabytes, which is the highest at that time. Further, the relational model provides a way to represent variable length constraints with an fixed length components. In the day of magnetic tape, strong variable length records like sales orders was easy every time you consider and you change a record and you had to rewrite the entire file anyway. However, it's impossible to do a online airline reservations in that way. New direct access data records had to be a fixed length. And in addition, normalization theory was the basis of hundreds of papers and successful tenor applications. That ensured the academic community would carry the model forward. Finally, by following open standards, including the structured query language, vendors created a buzz with dozens of relational DBMS products such as System RDB2, Oracle, SQL servers, Ingress, database, relational base, Perl, and Paradox and Access. And the prehistory. When I say that computer science is young, I mean that first practical general purpose computers were constructed less than a lifetime ago. The construction of more specialized devices for performing specific types of calculation has, of course, a much longer history. The oldest known example is probably the Anitkhedra mechanism, which could predict the timing of solar eclipses. It originated in the 2nd century before Christ. The first serious attempt to construct a general purpose computer was by Charles Babbage. He first described the design for his analytical engine in 1837, but the challenges of actually creating a working machine with the available technology were overwhelming. And XML data stores, which we have talked before, suppose that instead of normalizing or breaking a collection of XML documents, we could maintain it an XML data store. An XDS would have many advantages over a relational database, including seamless integration with user views as well as the all benefits of XML standard such as XML schema validation and the extensible style sheet language or document materialization. Would there be any disadvantages? No doubt about it. And XDS would duplicate data. But why? It says storage is free. What about data integrity? For that, we need only find the duplicated data and make it constant when necessary. Conceptually, this is merely an extension to cascading updates on foreign keys. And in fact, duplication has many benefits in relational database. If you don't duplicate item price in line time, you will never be able to record the original invoice. It means the duplication values will be identified when the product is highly sold and repeatedly we can use. Not in addition to data duplication, there are other problems to overcome such as uniqueness. For example, how many documents will carry quantity on hand? Which document is the official one? Which document reflects what's available in the inventory right now? And other hurdles in the XDS concept itself. Would there be a herds of XML documents wandering around the enterprise wherever they want? And would it be necessary to put a boundary around the some XML documents? For example, create a customer relationship management with XDS. If so, how do we do that? Yet another objection is that XML documents are hierarchical. But is this really a disadvantage? Well, my belief based on nearly 40 years of database design is that the human instruction set predisposes us to think in hierarchies. We have a class and a list of students in that a class is hierarchy, or we have students and a list of classes. They take a secondary hierarchy, of course. There are an n into m relationship benefit classes and students, but I suspect that's relevant only to designing a normalization. Thank you.